Fantastic. All right, if you are here to hear more about the active electrical cables, longer reach, and greater flexibility, then you are in the right place. My name is Chris Kapuscinski. I am a new product development manager at MOLEX. In my role at MOLEX, I look after the development of our 112 gig, our 224 gig SMT products, our bypass solutions, which is I/O via twin-ax to near ASIC connectors. And I also look after some of the development of our active electrical cables. Much of what I'm going to talk about is going to fall right in line with what Don at Credo was talking about. But I also want to take a little bit of a step back and make sure that everybody's kind of aligned on where we're at in terms of how we got here, and that AECs are but one solution as we go forward, right? So just from a problem statement sort of perspective, as Don was kind of mentioning, right, we want to be able to enable cost-effectively these links at 112 gig and even 224 gig, basically within racks and even across racks, right? But the challenge here is that as we go to 112 gig PAM4 and even 224, at that higher Nyquist frequency, we're seeing more and more and more insertion loss with that twin-ax. It's just the laws of physics, right? So what are we going to do? How are we going to be able to achieve basically trying to meet this 3-meter kind of target that has traditionally been in place within a rack, much less even possibly even longer lengths, 5 or even 7 meters between racks? So I'm going to put a little boundary kind of parameters, if you will, kind of around the solutions that we're looking for. One thing, we want to be able to adhere to this 28.5 dB IEEE insertion loss. This is specifically going to be more from just a completely passive channel. Now you might be asking, why is he talking about a passive channel if we're here for active cables? And I'll talk a little bit about that more in a minute, because DACs are not necessarily just yet done. They may be a prize fighter who is perhaps coming to the tail end of their career, but they are still going to represent a significant path forward for us, even at 112, just maybe not at the lengths that we had hoped or wished that they would be. That gets us to the second bullet, where again, I'm looking to enable kind of like these 3-meter lengths or even greater. And as Don was mentioning, I want to minimize the overall cable bundle size. Like that Experience Center does a great job of showing, the cable mass is significant. It is non-trivial. It's going to represent a significant challenge when we start talking about 112 and again, even 224. And I also want to continue to rely upon copper-based solutions if at all possible. They are going to be the most cost-effective solution going forward. So if we can utilize these copper solutions even at these higher speeds, then it is advantageous for us to do so. So from a channel sort of perspective, the rest of the presentation is going to kind of break down to kind of compare and contrast some of these passive solutions as well as the active solution. And the active solution can both be retimers in the case of AECs, but it could also be linear amplifiers. So I'm going to talk a little bit about some of the pros and cons of these different technologies, because essentially you might want to be able to incorporate all of these weapons within your arsenal in terms of ultimately coming up with the final design solution. Also, with these active cables, I get questions quite a lot from customers about whether or not bypass or flyover solutions are still required. And so I'll share a little bit more later on in the deck, looking at how these AEC and these bypass solutions kind of interact within your opportunities. So first, DACs. Everybody pretty much knows DACs. The pros are significant, right? Listed there. They are completely passive. They have no additional power that is essentially required of them, smallest latency, and they are going to continue to be the lowest cost solution. So if you can utilize them, you may want to consider, if your application allows for it, if you've got volume from a rack sort of perspective to accommodate them, they are going to be your best solution going forward. In fact, they are a baseline, right? But as I was mentioning, their lengths, their reach is going to be limited, right? I'm showing up here about 2 meters max. I think, Don, you were probably in that same area. That's assuming that you've done a great job of architecting the end-to-end channel. I question whether or not in all situations where we're mixing and matching different solutions within our end-to-end channel, 2 meters is going to be certainly a reach. All things being equal, those gauge sizes are going to lead to a larger cable bundle size, and that is going to challenge the routability. So just some pros and cons of DACs to basically consider. We move to linear amplifiers. So from a linear amplifier sort of perspective, I put this as a pro. It sounds kind of funny when I say adds latency, but really at about 400 picoseconds, it's not necessarily a budget breaker, right? And so from an AEC or retimed perspective, these alternative ACCs or linear amplifiers kind of have a pro when it comes to minimal latency addition. I do say that they are less expensive in quotes versus retimed solutions. We'll see how that plays out. Right now, I'm not seeing a significant delta between linear amplifiers versus retimed solutions at this state. So that's why I kind of put that in quotes. From a cons perspective, the challenge with the linear amplifiers is that, yes, while they may reset the loss plane, they don't eliminate noise, right? And they don't do any sort of signal conditioning. So if you've got a lot of crosstalk or noise within your channel, these linear amplifiers are going to amplify it. And that's going to be a real significant problem. It's really going to put greater dependency in terms of making sure that you've got that whole end-to-end channel as essentially minimized from a noise perspective, minimization from a crosstalk sort of perspective, right? Some of these linear amplifiers also do not provide the same sort of troubleshooting functionality. So PRBS generation and checking, loopback functionality, both near and far, these are not enabled with the linear amplifiers. So if you're looking to try and troubleshoot problems within your solution, within your application, linear amplifiers may not be the best opportunity or the solution for you. From a cost perspective, how do we weigh in against DACs? They're going to be approximately twice the cost of a DAC. So not significant and still, I shouldn't say not significant. That is doubling of the cost, so to speak, from what you might be used to. But relative to avoiding the optical cost, still a good solution. Let's take a look at retimers. So retimers, unlike the linear amplifiers, these guys do reset the loss in the timing planes. They essentially regenerate the signal, and we're essentially removing any and all of that noise, right? This gives us great freedom in terms of being able to have some independence in terms of where that ASIC is within the box, right? We've got much larger design freedom to be able to put that ASIC where we need it to be to potentially optimize other areas or other opportunities, other challenges that we might be experiencing within the box, right? Very, very, very importantly, and one of the most major benefits to the utilization of retimers and AECs is the ability to minimize that cable bundle, right? We can make these cables go 2 meters, 3 meters, 5 meters, and depending upon that retimer's loss budget and capability, we can do so at 32 and even 34 gauge twin-X. I'll show in the next couple of slides basically something similar to what Don showed in terms of just exactly what that means in terms of cable volume and the associated mass that it represents. The loss budget is extended by the parameters of those retimers, right? And we can enable these 5 meter plus solutions. Now, one of the things that we're seeing out in the marketplace, right, is a broad ecosystem of different retimed solutions, right? From Credo to Broadcom to Marvell to TI to Point2, all these vendors offer different opportunities when it comes to retimed solutions. Different power requirements, different loss budgets. That is absolutely wonderful because it allows us to actually have a very broad, diverse opportunity when it comes to AEC development and what might be best or right for our particular applications, right? Now, on the flip side, because you get nothing for free, right? On the flip side, right, we got additional power that is required. Again, this is going to vary by chip. It can vary by whether we're talking 56 gig, 112, 224. I show up here as just kind of a rule of thumb, about 6 to 12 watts. Some may be less, some may be more. It depends upon the form factor. Are we talking about 4 lanes, 8 lanes, 16 lanes in the case of an XD sort of solution? And they do add latency, approximately 20 to 25 nanoseconds. If you've got a latency sensitive application, this may challenge you a little bit. You might have to find other solutions in terms of being able to allocate your latency budget. They are going to be more expensive. particularly at low volume, about 2.5 times the cost of a DAC. But when you compare that against an optical sort of solution that is roughly, again, coming on order about 7x, AECs represent an excellent opportunity to be able to make those longer reaches both within your rack and across racks without actually having to go into an optical-based solution. You can continue to utilize copper even at these higher speeds at 112 and even 224 gig. So I mentioned this on the previous slide. I want to kind of drive it home here. Here are two different cables that I kind of show that basically kind of highlight the fact that not all retimers are the same, right? If you're talking about a higher powered retimer, then you're generally going to get a larger loss budget, right? And that larger loss budget is going to afford you the opportunity to go with a smaller gauge, that 32 or that 34, which is going to be great from a routability perspective. It's going to be wonderful in terms of ensuring that you've got reduced volume within your, or that you can meet essentially the volume spaces within your racks, within your chassis. The retimer diversity, of course, does lead to some trade-offs, right? Overall system power versus heat dissipation. So of these two solutions that I highlight here, we've got about a 12-watt retime solution affording us a budget of 35 dB. I can go farther with this cable than I can with the one below, which is only 6 watts and is offering only a 22 dB budget. But at the same time, with that bottom solution, I'm half the power, and I don't have to dissipate the heat that the top cables provide. So in many situations, depending upon what the application may be, I might actually opt for the lower power, lower budget solution versus the one up top. Again, this is all about trying to embrace a community where we've got the diversity to be able to select what sort of chips, what sort of cables, what sort of opportunities fit our particular applications best. The next slide kind of drives that to the final conclusion. It shows here a little bit about the minimum bend radius, the minimum bend space. It gives you an idea about the OD. So I'm pulling these 3 different solutions from a DAC perspective, as well as a linear amplifier solution at low power, as well as a linear amplifier, retimer at a high-powered solution. So you can see I can go about 2 meters. This would be the red box in the bottom left-hand corner. I can go about 2 meters with a 26 gauge cable. That's, again, kind of pushing it from a DAC perspective. It has the biggest OD at 12.7. I can go that same 2 meters with that low-powered retimer, and I get down to a 30 gauge solution. Now, that may still not be enough for you. It's roughly a savings of 45%, or it's basically, in short, only 55% the volume based on OD to that of a DAC solution. Still, that might not be enough. If I'm willing to pay the price from a thermal and power perspective, then I can go to the green line where I can do 2-meter cable in a 34 gauge twin ax, and I'm now less than 1/3 the volume. So this is some of the power that an AEC kind of brings, and it provides some of the decisions points or things to consider when looking at evaluating different AEC sort of solutions. So I mentioned that I would talk a little bit about bypass and flyover cabled solutions and their place relative to AECs. So I show here on this slide 2 different scenarios. Scenario 1, where basically I'm looking at just utilizing no bypass at all, basically the same PCB trace, and then the external cable from a DAC sort of perspective. I'll compare the active on the next slide. Versus a bypass solution inside the box, again, relying upon DAC. If we just look at the first solution, the first scenario, right, there is really only one opportunity where I've got to go all the way down to a 26 gauge DAC cable to be able to go 110 millimeters, which is about 4.5 inches. I'm not going to be able to do anything from a routing perspective with a 4.5-inch external cable, right? So in essence, scenario 1 without bypass, completely broken. With bypass, and assuming that I'm going to go about 250 millimeters with inside the box, now suddenly that 26 gauge DAC cable can get me about 1.7 meters. Again, there's obviously a number of assumptions in here in terms of the PCB material, the assumption in terms of the trace width, et cetera. So these are kind of rule of thumbs, right? But if you're still looking for a potential opportunity from a DAC cable perspective, bypass can certainly help. Let's take a look at the active channel, right? The AEC sort of solution. So here I'm looking at scenario number 3 and scenario number 4, where, as you can kind of see in the chart, in both those scenarios where I put the retimers into the modules, essentially into the I/O, now bypass is completely independent, essentially, from the external channel. And I can go as much as 2 meters with inside my box. Now, why on earth you would want to put 2 meters worth of twin-ax into your box is beyond me. But if it's something that you are interested in doing, come talk to me. But you can see here that depending upon what the cable gauge is, right, and what the associated power, whether in that light peach we're talking about a full 30, 35 dB sort of loss versus a lower 19 to 22, then we can basically go anywhere from about 1.1 meters up to about 5.5 based upon the assumptions. So in short, the main takeaway on this is that when you do use AECs, bypass now becomes essentially an independent decision. And you can use bypass in the box for other reasons, such as maybe I don't want to use a long reach chip within my box. Maybe I can get away with a medium reach, or I can maybe run my long reach chip, but I can do so at a reduced power, right? Knowing that I've got an opportunity to save some cost and save some thermal challenges associated with that, right? So that's a little bit in terms of how bypass and AEC cables kind of relate to each other. I'd like to then kind of talk a little bit about the call to action here. So as Don was mentioning, we would absolutely love to have more and more interaction. We love your feedback. We love your thoughts. Unfortunately, I am not the co-chair. I appreciate that. But actually, our director of standards, Scott Summers, he is co-chairing along with Don. The intention here is once again to kind of build this AEC ecosystem, right? And as part of that building of the AEC ecosystem, we want to, per that first bullet, make sure that we are aligning on some of these critical things like the bend radius, the bend space, other sorts of requirements from an OD perspective, understanding this diversity within the marketplace, right? At the end of the day, when we start talking about product availability, this is going to vary essentially by vendor and by the technology that is available, 56, 112, and even 224. When it comes to what we are doing from a MOLEX sort of perspective, please visit us on our booth. We actually are showing a live AEC running traffic. We've got a 112 gig switch up above in our rack. We are comparing that AEC versus a DAC. I kind of show a little bit of an eye pattern down there where the lower portion of the eye pattern is actually from our AECs. One of the things that you will see is that we are able to successfully complete the channel with that low latency, lowest cost DAC solution. And we are doing so at a bit error rate that is on average around 10 to the minus 7. So excellent in terms of being able to complete the channel length. Now that channel, in fairness, is only 1.5 meters. But if you look at the AEC, we're doing that same 1.5 meters at a bit error rate that's closer to around 10 to the minus 9. And this is all pre-FEC. You can see the significant difference in terms of the eye pattern below versus up above, right? And this is with a 32 gauge twin-ax. So it's a live demonstration showing you actually just the power of what these retimed AEC cables are capable of doing, right? I provide the link. If you want more information, please go to our website and check it out. My name, again, is Chris Kapuscinski. My email address is right there. So please, if you got any questions, we can take them now. I'm also happy to stay after. You can also email me. Please be patient. Show week here is a little bit busy. I thank you for your time. I appreciate it. And I'm happy to take any questions. Oh, yes, over in the corner.
Hey, I saw your pricing about AOC being optical cable being 7 times of the DAC. And what is the assumption about the 100 gig DAC or AOC in terms of base for comparison? In other words, per gigabit, dollar per gigabit sort of rate for DACs.
So I'm sorry, are you asking about like what is the cost per gigabit?
Yeah, for the 100 gig AECs.
Oh, that's a good question. I don't have that off the top of my head. What I'm going on basically is given where we're at from, so MOLEX not only makes copper-based solutions, right? We also do optical solutions as well. And so my 7x rule of thumb, roughly, is based upon our conversations between the copper unit where I'm at and the optical solutions in terms of what their cost structure is and then what they're going to end up having to sell the product for.
Right,
It is rule of thumb, right? It may be 5, it may be 6. We'll see how it plays out as the volume in the market grows.
Okay, thank you.
Sure, sure. Yes?
Yeah, can you say what retimer solutions you're using?
Yes, actually a multitude of them. So on our booth, we're actually featuring live with a Broadcom-enabled retimer. We are actively working with Marvell, TI, Point 2, and we're entertaining others. The challenge that we have is we can't boil the ocean, right? And so we've had to kind of narrow our focus a little bit. And so what you're seeing actually on our show floor is a QSFP-DD enabled with a Broadcom retimer.
Do you see differences in power between the different solutions?
Yes, absolutely. I didn't name them, but those power levels and loss budgets are the differences between 2 of the vendors I just mentioned. Sure.
Thank you. Great presentation.
Thank you.